So this technology that is interlinked block masonry system with viscoelastic link elements. Actually, if you recall, it is fresh in our mind. Just on Saturday, we were having an earthquake in Afghanistan, and a lot of people lost their life because of collapse of structures. So this technology we made specially for a common man who used to make their own houses. They used to live in that load-bearing kind of a structure, and for multi-story building, this technology can be used as a infill walls. So this is a very versatile technology and very easy to implement, and we really lower down the cost if the industry will come forward. So this technology will definitely will be a game changer as far as construction is concerned. So this next. So this technology is basically based upon the principle of damping. Here, the two type of damping plays an important role. First is viscoelastic damping, and another is frictional damping. So frictional damping, there are two components of the technology. In these two components, we are two different parts. One is interlinked block, because you don't couple it with interlocked block. This is an interlinking block, interlinked block, and the interlinking element we have introduced. And Naveen, next slide. So this is the interlinked blocks. You can see that we are having three type of blocks. One is stretcher block, that is a main block. Just half of it, we called it as a half block, and one another block is a corner block, because whenever you are making your house, corner should be toothed together. So for making the tooth at the corner, so that corner should not split in case of earthquake. So we have developed these three kind of a block. And one stretcher block can replace 6 bricks, and the cost of that brick, this one block is just at par with the 6 bricks we are what you are providing in a structure. So this is the interlinking elements. The interlinking element we have made up with this ply of radial rubber tire. So it is a very great industry. This is a scrap industry, and this is the bottom layer part of radial rubber tire. And it is used in a brick kiln, and a lot of pollution is produced by the brick kiln owners by burning it. So now the vendors, they are throwing it, they are burying it under earth. So we took it as a material. This is a viscoelastic material. This is a styrene butadiene rubber, and this is the tire of passenger car, not the tire of trucks, and because their tires are having different composition. So this is the tire of passenger cars. And these are the interlinking element. We have two type of interlinking element. One is the vertical element to resist translation, and one is horizontal element to resist rotation, because whenever the earthquake will come, our structure will be under translation as well as rotation. So these two kind of interlinking element we have developed. And this technology, this is the very simple one. We have not you need not to apply any mortar in between the blocks, and this is the kind of a full-scale model which we have developed at the Department of Earthquake Engineering, IIT Roorkee. And the test has been carried out on this is the shock table facility of IIT Roorkee, and you can see that the acceleration at the bottom and the acceleration at the roof of the model. So the earthquake force, the vibration will be damped at the bottom part of the structure itself. Even the person who is residing on the first floor, he will not come to know that earthquake is there, because all the energy we are dissipating in the bottom part of the structure. And you can see that on the top of the structure we are having very few vibration. Around 70 to 80% of the energy has been dissipated at the bottom part only. We have tested under the simulated earthquake excitation of MCE and DBE as per Indian standard codes, and the considerable amount of energy dissipation we have received in both the tests. Other test has been also carried out. So I would like to request my colleague Naveen to kindly play one video. In that video, it will be clear that how this technology will play its important role. So can we switch off the light?
Earthquake. Earthquake is a natural phenomenon and cannot be stopped. Thousands of people lose their lives during earthquakes due to collapse of man-made constructions. Each earthquake brings many challenges for the researchers. In the developing countries, masonry is one of the most affordable and adaptable building materials. In India itself, which is the second largest developing country, most of the population lives in masonry houses. As per census report, 84 million houses in India are made up of burnt bricks, and around 62 million houses are made up of mud or unburnt bricks. While the masonry is most affordable and used building material, the seismic performance of masonry construction is not satisfactory. Worldwide, many researchers churn their minds for improving the performance of masonry structures, especially during earthquakes. The Department of Earthquake Engineering at IIT Roorkee has developed a new, affordable, interlinked block masonry technique in the construction of earthquake-resistant buildings. The technology works on the principle of energy dissipation through damping and is successful in severe seismic zone 5 as per IS 1893 Part 1, 2002. The proposed research rolls over the development of well-designed, slotted concrete blocks and viscoelastic energy dissipator links made up of used radial rubber tires, encapsulated between very thin steel plates. These old and used rubber tires are used as viscoelastic materials because radial tires are made up of copolymer of styrene butadiene rubber, which is a viscoelastic material. Ply, that is the base part of radial tire, used for making viscoelastic energy dissipator links, has maximum part of steel wires embedded diagonally in the rubber, which enhances stability, strength, and viscoelastic property of the material. It is available at a very cheap cost in the kabaddi market, which cannot be recycled easily. Properties such as high strength, high tear resistance, high shear resistance, and high toughness are more effective for the development of viscoelastic energy dissipator links. Three types of interlinked concrete blocks, that is stretcher block, corner block, and half block, are developed to make possible arrangements of L, T, and cross in the masonry construction. Interlinking of the blocks is done with the help of two types of viscoelastic links, one vertical and one horizontal. No cement is used for the interlocking. Rather, the concrete blocks are provided with 4 vertical grooves to restrict translation and 2 horizontal grooves to restrict rotation under severe earthquake loading. The strength of concrete blocks is kept much higher than viscoelastic links for energy dissipation through the yielding of low-strength viscoelastic links and friction between the concrete blocks. The developed technology is tested under severe conditions on shake table and shock table test facility by simulating artificial earthquake excitations. Its seismic performance is analyzed experimentally. A full-scale housing model with maximum load-carrying capacity is made on the shake table and tested under series of simulated earthquake motions as per IS code 1893, Part 1, 2002. Peak ground acceleration of 0.18 g and 0.36 g, that is DBE and MCE of zone 5, considering soft soil condition is applied. Along the height of the model, there is a reduction in maximum roof acceleration as compared to base motion without any damage in the model. The energy imparted is completely dissipated through friction and viscous damping of viscoelastic links. The model retains its original shape and position after the tests. Further, increasing the severity of the test, single-storied and two-storied models are also tested on shock table by giving impact type of loading. 3 consecutive shocks of increasing intensity are applied.
So this is the two-story model which we have tested. Even we kept the flower boss and all that, but even it didn't feel the lemon.
In test results, it is seen that peak acceleration at the roof of model is significantly lower than the base of model without any distress or damage in the model. It underlines the complete energy dissipation through viscoelastic links without damaging the blocks. The elastic plastic behavior of viscoelastic links reveals that the model regains its original position after completely dissipating the energy imparted during the shock test. Besides better earthquake resistance capacity, there are many advantages of interlinked block masonry system over the conventional masonry system. It is more rational and simple. It ensures speedy construction work. It has high energy dissipation capacity, construction at the site, and lightweight blocks, like blocks with fly ash, may also be used in the construction. So, what do we expect from the industry? Industry intervention is required so that well-slotted concrete blocks and viscoelastic links can be readily available in the market, and to spread awareness about the developed technology.
This is the one developed as an interlinked block masonry system, and for industrial application, because you need the block. So we made the block making machine for making 1,000 square feet of house. You need 5,000 blocks. So we made that one machine in which per day you can make 500 blocks per day. So Naveen, can you play that just a second, if that machine? So this patent has been already granted for this technology. So we are having patent for that. Just so this is the which people can make a block. So in one day, 500 blocks can be made. And the links are available for market. So actually, we can make it. So it can be used as an if you are having any query, so I would like to invite our Dr. Pankaj Agarwal, so he can come up, and if you are having any query, so we can answer.